All right, good morning. Welcome to FOR 242. Glad you're with us. Today we are going to make some patch cuts in an area that will catch the morning sunlight. So on the theory that something that has just spent the night out in the woods would like to get up and have a bite to eat in a nice sunny environment, and a patch cut is a great place for a critter to find food, whether you're a deer browsing on twigs or some bird that likes to nest or eat in young regenerating forests. So we are going to use the digital elevation model, which is this guy here, not the hillshade, the digital elevation model, to find those east-facing slopes. So of course, sunrise is in the east, and a slope that is facing that direction is going to receive that light first thing in the morning. So we are going to have to generate two new layers from this digital elevation model. One of them is going to be slope, and the other one is going to be aspect. Aspect is the compass direction that the slope is facing. So a slope facing 90 degrees is facing due east, so east that way. If that makes sense, it will shortly. So this one, you see how it's sloping down that way. I think we're mirrored here, so I think we're facing that way. And that means that this is a east-facing slope. So the sun is going to rise over here, rays of light hitting here. So we are searching for those areas in here that are sloped enough that it's not flat ground. So a pronounced slope and sunny in the morning. So search for tools. Slope. And the slope we're going to use can be 3D or Spatial Analyst. And remember, these are two different packages. It's the same tool. And the way that you buy ArcGIS, if you are a private consultant or purchasing for your company, is that you buy packages. So you buy the base ArcMap software and then some packages. And Spatial Analyst is one of those packages. 3D Analyst is another one. And they all contain different tools, except those tools that are common to both. So slope is such a common one that if you're paying for 3D Analyst or Spatial Analyst, it comes with it. So pick either one of those. The input raster is the digital elevation model, not the hillshade, and the output raster shall go to your Google Drive file stream, and the output measurement shall be %rise. And that is all there is to that, so your screen should look like my screen. Digital elevation model, not like mine, to the Google Drive file stream, %rise, method planar, Z factor 1, OK. And that'll take a minute. That's pretty quick. And this is our slope model. And there it is. So you can see the steeper areas in red, steepish areas in yellow, and the flatter areas in green. And we can reclassify this, which we'll do in a moment, or we can display by category. So if we double click or right click and go to properties, you'll see that this is defaulting into a classified symbology. And we have 9 classes. Let's first change that to 3. And then we can go and do the thing that we often do, which is look for wettish areas and steeper areas. So here we have in blue 0 to 2, so flat ground will collect water. We don't care about that. And then we have the steeper areas in red. So we essentially have the French flag. So that French flag symbology ends up being pretty intuitive on the map because we have dangerously steep slopes in red. Red means danger, and then blue means its own particular kind of danger. And none of these are necessarily evil, but you will want to go out there and check and see what's going on. So we want to have a slope that is greater than 10%. So we're going to classify this again, and now we want just 2 categories. And we want to know those slopes that are at least 10%. And remember, that means 1 foot of rise for 10 feet of run. So for every 10 feet you go this way, you're going up 1 foot. So 10% slope. And I'm just going to display that, as no color, and that as black. So now we can see all those slopes that are steep enough that they'll catch some light. So now we need to have the aspect. And again, search for tools, aspect. And then aspect 3D or spatial analyst, same situation as the slope tool, where the input raster is the digital elevation model. And the output shall be to your Google Drive file stream. The method is planar. And the difference here, geodesic just accounts for the slope of the Earth, which is trivial at this scale. So at the scale of woodlot, the slope of the Earth, as in the globe, doesn't matter. So we're going to go with planar. Completed. And there we go. And that is that. And it color codes it according to north, northeast, east, all the way back to north. But what we want is not this. What we want to see is from, what I have written down here, 45 to 200 degrees. So that's sort of north, northeast to just past south. So it'll get a goodly amount of light. And let's put that into 3 categories. We'll say from 0 to 45 and then to 200. So that shows what we're looking for here is east is going to be 90 degrees right on here, but we're giving it somewhat of a range on either side. And we can see that we don't have many south-facing slopes here. We have more north-facing area. So, okie dokie. So now I'm going to make that no color. I'm going to make that no color, and I'm going to make this a bright and sunny red. And now what I can do is change the transparency on this, and that is going to allow some overlap. So let's go ahead and zoom in here and see what we're looking at. So we can see visually there are some areas. I'm going to turn off our hill shade and elevation model. We can see there's some areas where we have that kind of overlap. And those are those areas. So you see there's this lighter red here, and there's this darker red here. Because this red is always transparent, when it's overlapping with a black polygon, it is going to be this darker red. So all of these are areas that we are potentially looking for. So if we put a patch cut on top of that, that's the job done for the day. So that is neat. It's visual. But we don't want visual. We want to actually manipulate the data to tell us exactly where all of these overlapping areas are and get rid of everything else. So to do that, we're going to have to actually reclassify the data. So right now we're displaying by classes, but we want to actually change this data so it's only showing zeros and ones. So in this case, anything from 0 to 10 is going to become a 0. And from 10 to 105.1792603 is going to become a 1. And then I'm going to do the same thing here where this is a 0, this is a 0, and this is a 1. And then when I multiply these two things together, anything multiplied by 0 is going to be 0, and anything multiplied by 1 is going to be itself, in this case, also 1. So we're going to end up with a lot of zeros and ones on the map, where the zeros are where either none of the conditions are met, or only one of the conditions is met, and the ones are going to be where both conditions are met, meaning that it is a east or south facing slope, and that slope exceeds 10%. So those are our criteria. So search for the tool, reclassify. 3D analyst or spatial analyst, same tool. So the input raster, we're going to go with slope TIFF 1, and I'm going to classify that. And this looks exactly the same as the other. So just like when you're visually doing this, this is the number of pixels that have this value. So there's more pixels that are lower slopes and fewer that have a higher slope. And just like before, I can type in 10 as my break value. And I was going to separate this data set out into less than 10 and more than 10. Okay. And now I need to change this value just by clicking on it. So if I click here, left click, it allows me to change that to a 0. And I can change that to a 1. Now I also have the option to type in no data here. And that will just completely remove it and no data will exist for that cell. That's not what I want to do right now, so I won't. And this, again, will go to your Google Drive file stream so you don't lose it. And we'll hit OK. So now we can see what this has done, and we have zeros and ones, where zeros are the lower sloped areas displaying now in green, and the ones are the slopes 10% or more in purple. So now we're going to do the same thing for the aspect. Search for the tool. Thank you. Reclassify. Input raster is aspect, diff1, classify. And just like before, we have 3 breaks. And those break values are going to be 45 and, what did I say, 200? 200. And just like before, so this is our go, and both of these are no go. So 0, 0, 1. Okay. So again, changing from 0 to 45 is a 0, and a 0 for 200 to 359, and that is going to be a 1. And this goes to your Google Drive file stream, so make sure that you have 0 to 45, 45 to 200, 200 to 359.999,756, and 0, 1, 0. Okay. So now we have another 0 and 1 data set where we have ones that meet the criteria that are east or south facing and zeros that are not east or south facing. So now we are going to search for the tool Raster Calculator. And this is where rasters come into their own as an analytical tool, because every cell on this map is going to align with another cell of another layer. So the cells of this one line up with the cells of this one. And when I do math, it's just going to take the cell that is on top of the other cell, so the cell from this one that is on top of the cell from this one, and for every location on the landscape is going to do whatever mathematical thing I tell it to do, in this case, multiply. So Raster Calculator. So again, the logic of this is anything that's 0, 0 times 1 is 0. So if only one of these is a 1, it doesn't matter because it's going to be multiplied by the 0 from the other one. If they're both 1s, if both criteria are met, then it is going to remain a 1. But if one of the criteria is not met, you'll have a 0 in that equation, and anything times 0 becomes 0. So the equation we're writing here is the reclassified aspect times the reclassified slope. And the output is going to be to your Google Drive file stream. So reclass aspect 1 times reclass slope 1. So zeros and ones times zeros and ones, giving only the areas where both criteria are met. And now we have this black and yellow, where 0, we don't have both of those things in the same place. And in yellow, we have where both of those things are present in the same place. And you see that lines up with the visual assessment we had before, precisely, which is exactly how it should work. So now I can uncheck those things, and I can go into this reclass aspect symbology, and I'm going to change 0 to no color because we don't really care about it, and we're going to change the 1 to red because it's a nice sunny spot. So there we go. And I'm going to right-click on this and zoom to layer. And that shows all of the areas that are acceptable for the patch cuts. Now what you're going to do next is exactly like last week. with the exception, not last Tuesday, with the exception that you're using a different guide to your operations. So you're going to look for a stand in the forest inventory, and you are going to, let's set a transparency on this. And remember that if you drag this above there, that's how that gets on top. And we can set some transparency here, let's say 50%, and OK. So now we're going to use these sloped areas to select groups of cells. And let's see, what criteria did I give you for that? 4 to 10 cells per patch, and no more than 4 long or wide. So we want sort of patchy areas. And we want to use the selection, interactive selection method, add to current selection. And that will allow you to select multiple patches that aren't connected to one another. So I'm going to use the lasso tool, and it doesn't have to be completely containing a perfectly sloped area, but it just has to be sort of mostly meeting that criteria. So let's go ahead and do that. So there's one, and if I want to add in some more to that, I can do that. Add in one more. And then I have some nice area down here. There's a bit here, and a bit more down here. And then I'll make a skid trail that connects all of those things. So just like last week, new shapefile, laying out the skid trail. Try to avoid skidding over 1,250 feet is the criteria I gave you. And you'll just connect those. And all it has to do, there's no branch trails or anything. These are going to be patch clear cuts. So go ahead and make that trail, connect them all, and then you're going to go through exactly the same steps as last time to calculate the saw log volume and the pulpwood volume. And you've got that video from last week, so go ahead and refer to that if you need to. But I've also included the sort of cheat sheet down here of how to calculate every one of these in text form if you want to. So you have to do that, but if you want to read it out on text versus watching me do it on video, you can do it that way, or either way, or both. So that's that. So you're making patch cuts in a space that will get morning light. That's the short version of that. And we want to know what the total value is, and the map should communicate exactly what you're doing and how you calculated everything out. So that should keep you busy for a little while, introduce you to some of the basics of raster analysis, and give you a sort of window into wildlife habitat management through silviculture. So I hope you're all having a good week. I hope you'll have a good weekend ahead of you. Stay safe, have a good time, and I will see you next Tuesday.